Welcome to the SIG Cloud Provider July 10th, 2024 API Server Network Proxy Working Group meeting. As always, these meetings are part of the CNCF. We are beholden to the CNCF rules, so please obey those rules, most of which amounts to please be kind, considerate, and inclusive of others. Today, we are going to be going over some recent changes from Willow. And with that, Willow, go ahead and take it away.
First change is I have a PR up. Let me grab the link to that super quick. That PR adds end-to-end tests to the repo. Pretty much, I think currently there are integration tests that run. They run an agent process and a server process and confirm that they connect to each other, but there's nothing that actually spins up a Kubernetes cluster and then deploys it on the Kubernetes cluster. So I have a PR up, which I just dropped the link to, for end-to-end testing. And current status of that is I need to go back and just unfortunately it seems to require me to bump it from 1.22.2 to 1.22.3. I couldn't figure out how to not make it do that. Like I when I ran go mod tidy, I asked it to downgrade to 1.22.2, and it complains that the end-to-end testing framework package requires 1.22.3, which is counter to the documentation on their repo. So I don't really know what's going on with that. And that is blocking the second PR, which is adding a leasing system to determine the number of currently running KMP proxy servers. So currently, the way that agents connect to all proxy servers is by they first set in a connection to a load balancer, connection request to a load balancer. Load balancer routes that to a server, and the server responds with an open connection as well as the current count of the number of KNP servers. Currently, there's no that count that's returned is provided as a static command line flag, so you have to restart the KNP server if you want to scale the number of KNP servers. So the PR that I have up, which is pretty much ready, I think it just needs linting. The main logic parts of it are, I think, are in a good state. It mostly just needs linting on some of the command line flags and just making sure I documented everything properly. Let me just grab the link to that super quick. So it does it with a lease-based system. What it does is the proxy servers, the proxy agents actually, instead of getting the count from the proxy server connection request, the proxy agents will just read from the Kubernetes API server the number of leases that are currently valid with a certain label selector that you provide to the KMP agent. And what the plan is to point that lease, point that to actually count the number of API server leases, because in most use cases, there's a one-to-one mapping between KNP servers and control plane nodes. But since that might not always be the case, it's left up to the user to determine the label selector to actually use for the leases, and that's pretty much the bulk of the PR.
So one question I have, and this came up on a side channel, so I apologize. Is there a reason we couldn't just have the KNP servers themselves grab leases and do a count that way?
Yeah, so that's definitely something we've considered. I think that the idea is, since the most common use case is for there to be a one-to-one mapping between KNP servers and API servers, to just go with that first. And if necessary, either we can add to, if it's like desired, we can add lease controller to the KNP servers. And since the KNP agents, you can just point it to a different label selector, you would just, once that gets added, it would be pretty trivial to just change which command line flag you're passing to the agent.
So no offense to the people who told you it's the most common, because it may be correct, but I think that the reason you're being told that is because that's how Google does it.
Makes sense.
I don't actually think we know how anyone else does it. Now, the interesting thing here is Imran's here. So in fact, I think it would be interesting to get Imran's input on this.
So when you say one-to-one mapping, you are talking about both of them, both API server and connectivity server in probably the same pod and using a UDS socket. And that's one-to-one mapping?
I meant rather that each control plane node runs a KNP server instance. That's, yeah, I shouldn't have said API server.
Right.
So using a UDS socket, right?
Between yes. Yes.
Yeah. So that's not really. Well, that's. I would assume it would be a use case prevalent in other places. Microsoft or AKS uses MTLS between the API server and the connectivity server. So it's not really one-to-one, but the connectivity server is in a separate deployment of its own.
What's MTLS?
It's a way of doing SSH.
Okay.
Yeah, mutual TLS certificates between establishing communication between the API server and the connectivity server.
Okay.
Yeah, so I think if that use case is considered, then that would cover all the scenarios that would be possible in terms of authentication between API server and connectivity server.
So one thing that I think is useful here is maybe a little bit more background. Do you mind if I go ahead and give it, Willow? So the problem that Willow is trying to solve is how you change the number of API server network proxies that you're using. So the way we do it today, and when I say change, I really mean increase. So the way that we do it today is that each of the agents will periodically try to connect to yet another API server or network proxy server so that it can see if the load balancer happens to distribute it to the right place, it hits a new one and it discovers there are more than it had originally thought. And the problem with this is we don't want to be constantly polling and making these connections, so we only do it once a minute. The idea is that by watching, I'm assuming it's watching the leases, if that number increases, the agents can automatically realize there are new API server network proxy servers available and can more actively try to establish that connection. So I think that's specifically the use case that Willow is trying to solve for. It's really nice. The tricky thing then is what figure you're watching. And so the figure that she's watching is the number of API servers, the lease that's done for API servers. That's a convenient already existing lease for Google. And this is why I was asking earlier about, would it make sense to just add another lease for the server, the API server network proxy servers, so that in fact, rather than, sounds weird, instead of using a proxy figure, you actually have the real figure. And it sounds like it would be useful for Microsoft if we actually had an option to use the real figure. I mean, we could control it, like it wouldn't have to. It's not necessarily true that we have to use the lease, but it sounds like, at least for Microsoft, it would be good if it did.
Yeah. I will also note that the current way of pointing it to the API server lease, that currently the API server leases are garbage collected and expire every hour. So if an API server goes down, it'll be slow. The KMP agents will be slow to get an updated count because it'll take a really long time for it to get garbage collected. So currently I have a PR up to reduce that, but if we just make a separate leasing system, that becomes kind of a moot point and don't have to touch the main API server lease duration.
I mean, I'm a fan. Imran?
Yeah, just to recap, if I understood correctly. So right now, the PR is based off the API server leases, right? Using the existing API server leases, and it would be nice and it would be helpful if a new lease is set up, especially for the connectivity server lease. Is that correct in my understanding?
Yeah, the only thing I'll say is that the current PR is actually agnostic to the lease. You provided a label selector for the leases. So the plan is the plan was to say either use the API server lease or roll your own lease controller. But I mean, it sounds like maybe this is the first PR with the label selector can get merged, and then the second PR can happen that adds a lease controller.
Cool. Yeah, makes sense.
Yep, I think that makes sense. And I mean, the only other thing is and I don't think there's a problem with this, but we always, where possible, want to be backwards compatible. So, new behaviors should have a way of turning them on or off, and they should default to off.
Oh yeah, so the current way I have it is that it's back. Yeah, it's so the server count. So actually, the way I wrote it, it has the way that it reads the leases. Either the agent or the server can read the leases. So that way, it's backward compatible if there's old proxy agent versions. The servers can determine the lease count and then return that in the connection request like it is in the old way to the to the agents. But yeah, I'll definitely keep in mind backwards compatibility.
Cool. Sounds good. Awesome. Thank you, Willow. And yeah, we've got, I know I have a small backlog of reviews to do. All right. Did anyone have anything else they wanted to go over?
No, not really. I did find an issue regarding in the HTTP Connect module where because of how we write the error message to http.error after the hijacking of the connection, it doesn't really propagate the error, and it doesn't make sense because one would have to write the error message directly to the connection object. I will submit a PR soon on that front.
Okay.
But if folks can look at the write-up and provide feedback, that would be great in terms of possible solutions or on any improvements that can be happen on that front.
Okay, will do. Quick question on that. You're making me sad. I'm sorry. You guys are using HTTP Connect mode rather than the gRPC mode?
Yes, for now, yes, HTTP Connect.
All right. It doesn't make a huge difference yet. And I don't know if I'll ever actually find the time. I just keep threatening to find the time. But I keep wanting to make a MUX version of the connection between the API server and the network proxy. So that we don't have to keep reestablishing connections. And one of the things with the HTTP Connect is it's not good at running in MUX mode. So I probably am, if anyone does it, myself or anyone else, my guess is we will probably only be muxing on the gRPC. So just as a warning, like if that ever actually happens, I can't promise. That sort of efficiency gain is probably only going to be seen on gRPC.
I think we had this conversation in the past about this capability of muxing on gRPC, and it doesn't really happen quite efficiently on HTTP Connect. But as I understand, we are not using UDS, and we are using MTLS for the API server connectivity server communication. So I think there is something missing, I would say, if I remember correctly, as per the comments in the API server, I think connectivity client code base code, where I can't simply remember. There was something missing that would not allow gRPC to be used when you're using MTLS. Something like that. It was like that. You can find it. I'll share the link.
Yeah. Okay. Yeah. I don't remember that. It's possible. It is certainly possible. I don't remember anything like that, but I don't remember everything as much as I might try. I mean, yeah, the gRPC should be after the connection has already been established. So, yeah, I don't know. Sounds worth doing, because yeah, I could have sworn that when Google first started using it, we were doing gRPC over HTTP with MTLS until we switched to UDS, but I could be misremembering. All right. Anyone have anything else?
Quick question about muxing. Could you please give a little background on this?
Sure. I'm going to use an analogy. Should always be suspicious of anyone doing analogies, but I think it makes it easier in this case. So if we actually look at what's going on here, there's a connection between the API server and something running on the data plane, right? So it might be a webhook server, it might be the kubelet, but the API server is trying to talk to something. Now that communication happens over 3 segments. So there's a segment between the API server and the network proxy server. That's the segment we're talking about. There's a second segment that goes between the network server and the network agent. And then there's a final segment between the agent and whatever the final destination is. Let's say it's the kubelet. All right. 2 of those 3 segments are actually tunnels, where we're putting TCP traffic over TCP. So it's 2 layers of TCP. And we need to, so once you get onto the agent's running in the data plane. We assume that the data plane network is secure, so we don't have to secure that segment. The other 2 segments, we don't make any assumptions about, and we try to secure them one way or the other. Kind of going back to some stuff we already talked about. Google secures it by going, the network server or the proxy server has to be running on the same VM as the API server, and so we're just going to secure it by using Unix domain sockets, which basically means we're writing all our traffic through a local disk. So, with appropriate permissions set so that we believe that that's secured. Microsoft is apparently doing it through HTTP over HTTP over SSH, secured by mutual TLS. So that's securing it. Okay, so we've established a tunnel that has been secured. Now, between the API server and the agent and the API server network proxy server, we also establish it. And here, I think all of us do SSH over TLS to establish the connection between the server and the agent. So then the question is, how many such tunnels are there? And the normal way of doing it is there is 1 tunnel per agent server pair, right? So If my agent is connected to 3 servers, then each agent has 3 tunnels. And if there are, let's say, make the math easy, 3 agents, each server is also going to have 3 tunnels, right? So there'll be a total of 9 tunnels between the servers and the agents. I can run 1,000 connections over that segment. And I have 1,000 connections divided across 9 segments. So obviously we're sending, you know, this is what I mean by muxing. So we're sending many, we're handling many connections over 9 actual. So it's 1,000 virtual connections being run over 9 actual TCP connections. So now that's the muxing that we have between the proxy server and the proxy agent. If we look at the first segment I was talking about between the API server and the proxy server, every time the API server wants to establish a new connection, it's actually today creating a new tunnel segment. So even though I only have 9 tunnel segments or 9 tunnels on that second segment, in that same scenario, I would actually have 1,000 tunnels established between the API server and the proxy server. That seems highly inefficient, especially since for poor Imran, mutual TLS is expensive, right? I mean, we're talking expensive in hundreds of milliseconds, but you know, hundreds of milliseconds per connection, especially if we take it to the real world scenario and go with everyone's least favorite webhook calls. If the API server needs to make 10 has 10 webhooks that need to be invoked, you've got 10 seconds for them to complete. And if this includes mutating webhook calls, which means, and it's not the first one, but the second or later webhook call does a change, then the API server is going to go through and rerun all of the webhook calls. So that 10 webhook calls just became 20 webhook calls. Each of them take 200 milliseconds. I have just eaten up 4 seconds of my 10-second timeout for my API server write request to succeed just on mutual TLS, right? So if we can get rid of that initial connection requirement, we basically just saved 4 seconds, and a substantial number of webhook calls could now succeed, which weren't going to succeed before. So, I mean, just kind of level setting why we might want to do this. So that's the idea, is that basically if the API server has, you know, knows that it has got an already working connection and can reuse it by muxing, then yeah, we do get a real win there. Did that answer the question?
Yeah, thanks a lot. It's actually a really exciting change. Yeah, that's really nice.
Yeah.
Thanks.
Thanks, Walter, for explaining. I did find the link to one of the comments in the it's in the API server code. Sorry, it's in the Kubernetes code base. I just wanted to know if that comment is still valid. It says proxy protocol of gRPC is not supported with TCP transport at the moment.
I don't know. That is a very good question. I would have to, okay, excuse me, I'm just gonna, so this is the one you're talking about, right?
Yeah, line 72.
Isn't there a, there it is. Okay. It's going to be Chow. Yeah, it's Chow. All right. I could be wrong. And unfortunately, Chow is awesome, but Chow's off working for a non-Kubernetes company at the moment. I keep trying to tell him to come back, but it makes it sort of awkward to ask him these questions. I think, but I'm not positive without doing some digging, that what's going on here is that we're conflating HTTP Connect with with the idea of it being TCP. And while I believe that the proxy protocol won't work with TCP, or yeah. Yeah, I think this just requires, honestly, I think the answer is it requires a bit of investigation. It may be correct, but my impression was that the problem was HTTP Connect, not TCP. Someone is going to have to confirm that. So when we get around to actually trying to make the change, someone's going to have to confirm that. I don't see why it would be true, but until someone tries, we won't know for certain.
So this muxing on gRPC, is this something in the pipeline that you're planning to do, or is this because if the statement in line 72 is not true, and we can use gRPC with TLS, MPLS, TCP, then I'd like to work with you in order to have that muxing capability merged.
Okay. Yeah. So the muxing's already in gRPC because we use, and I know this because we use it between the server and the agent. Now, I think what's interesting, sorry, I'm going to bounce around just a little bit. I mean, gRPC, yes, yeah, okay. So what I was going to say is, I mean, so gRPC, I mean, even in just the examples we have, right, the front end client is the API server. And we have the API server connecting over gRPC, over gRPC to the proxy server, to the proxy agent, to the HTTP server. So if I take a quick look at the test client, we see that it's using CA cert with keys. So using MTLS. So, I mean, the weird part here is, as far as I can tell, even our own test code is actually doing TLS over gRPC over TLS. So the tricky part with the muxing is actually the connection reuse. So all of the fix has to happen in the connectivity client code. And in fact, I'm going to be completely honest. One of the things I like about Willow's change is that I'm hoping, is that I'm hoping it gets us closer to testing the way the API server does, because it will make it easier to actually test this change where we're using a better E2E framework. But the tricky part is that when the API server says, hey, give me a connection, someone has to write sort of pooling logic that tries to get see if there's an existing connection to the right place and hand that back for reuse, right? That's where all of the real work for this change is going to be. Awesome. I actually also need to run, but yeah, I'm all for working with you on this change, Imran. Like if you have cycles, I can try to make cycles and we can try and get this done. And that includes if you want to book some time with me to go over actually what it would take to migrate from HTTP Connect to gRPC. I am happy to sit down with you and go over that as well.
Would love to. How shall I reach out to you in terms of setting up a meeting? Slack or?
Slack works. I'm going to stop the recording for a second. Well, not for a second. I'm going to stop the recording. So thank you all. Hang on.